again, changed outfit. Wow. From yellow to, what's this color? A combination of gray and, what do you call this one? Maroon? And still yellow short. Okay, guys. Hello. Uh, Hello, guys. I'm taking my coffee now. Wow, coffee for this is very cold. It's already October 23 or something like that. What's the date now? Let me check. Never mind. Okay. Very cold. Still the AC. Okay, guys. Okay. For my first sample problem regarding heat transfer, that's only conduction. Now, today we will be able, at this moment in time, we will be able to present a combination of the conduction and convection. Okay? So guys, it is possible to combine the three also. We have a conduction, convection, and radiation. I don't think so. Anyhow, I will research a combination of the three if there is, right? In which we will be able to solve the, emissivity like that. We're having the Stefan Boltzmann constant, something like that. Okay, but it's very difficult, I think so. Okay, but let's do research. Give me time to research for that. Okay, so again, let's review terms before going further. Okay, three types of heat transport or heat transfer. First, conduction. This is a heat transfer through the solid medium or solid substance. So meaning there's a movement of the molecules in the solid medium or solid substance. Okay, now when we speak about convection, this is a heat transfer governed by the movement of molecules through the fluid or liquid substance. And then the heat transfer through radiation, it's simply governed by the radiation emitted for a particular rays or emissions or whatever from point A to point B, something like that. Okay, that is more applicable nowadays in surgical operations through laser, okay, and X-rays in our chest during our physical examination in a doctor. Chest X-rays and laser, light amplification, simulation, emission, radiation. Okay, especially for the operation of a cataract, like that, or internal organs inside our body, then we need a laser operation. So this is the application of heat transfer through radiation. Okay, the third type, or simply the transfer of radiant heat of the sun through the planet Earth. This is also heat transfer through radiation in our day-to-day life. In this planet Earth, that is heat transfer through radiation from the sun, and then it will radiate to the planet Earth in order for us to survive, the plants, animals, and all the living organisms in our ecosystem. Okay, any questions so far? Okay, let's talking about in the environmental point of view. Okay, there's a lot of heat transfers every day when we make a coffee like that, in our refrigeration system like that, AC cooling system. It's always like that, always cooling, cooling and heating. That's a normal process in our survival here on Earth as a human being, not only for the equipment and facilities and technology, but also for human being. We will maintain our body core temperature, or else we will develop fever. Okay, fever, F-E-V-E-R. Too much temperature inside our body, and we cannot control that anymore. That's why we need cooling system also as a human being. And that's also example of heat transfer. Okay, through convection already. Or it's a combination of two, conduction or convection too. It's up to you. Just focus on the main principle and concept of this topic. Heat transfer through convection, conduction, and radiation. Problem number 2. But before going to that class, I need to introduce the three types of material balances. Okay, we have the first type will be the transient, second the continuous, and the third will be steady state. Okay, the transient usually undergoes non-steady state like that, and be continuous. After one tank, it will go to another tank, one vessel, second vessel, third vessel. It will go continuously, and then you have a material balance separately out of that. So that is continuous material balance. So in a material balance, or what we call that in engineering as an overall material balance, we have also the corresponding energy balance and the component balance. The component balance usually deals with the mole fraction and the mass fractions, or percent by mass or percent by volume. It depends on the situation. Okay, that is component balance. So of course, the material balance, OMB, component balance, and the energy balance. Okay? Like that. But there are three types. We have the transient, continuous, and the steady state. The mode of how to balance. Okay? You get the point? Something like that. So we can understand what's going on, like that. Okay, so this is really the basic tool of engineering student, okay? Or in short, being an engineer. If you don't know how to balance, patay tayo dyan. Okay, we always balance the amounts. What comes in, what comes out, what's generated, what's accumulated, what's consumed. It's gonna be the job of the engineer to do that. Okay? Like that. And we are very, very concerned on the environmental impact also. Okay, because what being released to the environment, okay, can really destroy our natural resources that God gave to us. Okay, and then we need to measure the amount of harmful substances or any gases that will be released in the environment. Okay, through that also it has a relation to balance the energy. When you mean of energy, of course, there's always amounts of substances, or else there will be no energy balances at all. Okay, you get a point? Something like that. Okay, now, so mag-show lang ko gamay nga example sa overall material balance. So, guys, it's not like that you will always say input is equal to output. There must be a reason why it becomes like that. Okay, so that is only for steady state. Okay, but what if it is non-steady state? You cannot use that anymore. Okay, something like that. So okay, it will start with, hello guys, thank you so much for watching Mr. Chisif Cantal, for passing by my live streaming. This is second live streaming, second segment. Oh my gosh, it's gonna be like, so na ako pag-draw. I'm not good at drawing. But I wonder why when I was in elementary level, I used to represent our school in a drawing competition. Really. And then during the actual, I remember this in my memory, and then during the actual contest, I'll never go. Okay, and then our valedictorian and the other, other honor student, okay, in fairness, okay, because we are always, in the honor rules, something like that. I'll sleep at that time. And then they went in my house. Uy, Sotero, apil baya ka sa drawing contest. Uy, kala na to, krumang ka, uy, huwag mong ko sa akong hunahuna, wag ko ni apil. But the main reason for that I'm not joining because I don't have the resources. Okay, I don't have the color pencil, I don't have the katungkot lang kuan. Mauwaw mo ko musulti. Okay, so because we are not rich, something like that. So I'll just being a kid and in the house playing something like that, and about it I'll sleep. Okay, they went into my house. So Turo, ikaw ba ang contestant sa drawing? Sila sa science, yung isa sa mathematics, yung valedictorian na mo sa mathematics. Then yung isa, yung sa science. Then ako sa drawing. Charot! O, di ba? Okay. I remember that one really. Okay, and then wala lagi kanitong nga kalay sa Dimo Sotero mga tuwa, jud ko ni apil. Okay. Siya, ay problema sa ko dikit. Tagaan man tani ma'am ko anong mga gamit. Okay. Pero honestly, nag-uol ko kay wala ko yung mga kuan, mga gamit sa drawing. I remembered also, I have also a little talent in drawing, but as I grow older, my talent in drawing was lost. Something like that. So it's all about practice pala siya if you develop your talent, because sometimes somewhere along the way it will lost also if you will never improve it. That's one example, right? Okay, then it loosened my mind even though I have a little talent for that. Okay, it's gonna be like that. You should use, what do you call this one, you should develop so that you can improve your talent, something like that. Okay, that's the reason out of that. Okay, and then I never joined for that competition really. Okay, sila rato dito. Okay, nakaloka. Okay, that was a memory only. And then going back to this I have to show you. Just like katusang kuan when I joined, editorial writing competition in Cebu nga National High School. Okay, it's not on my mind really to wait for the announcement for the winners. I was now in the school and they are telling me, Sotero, nakadaog baya ka? Ha? Oh, because I don't expect that to happen. Okay, something like, oh my gosh, really? Then after that, we represent our school or represented our school in going to the regional level, something like that in Silliman University for the particular competition in journalism. I remember that also. We go to Santander and traveled with a murag boat siya ba? Okay? I am very young at that time. Really. Okay? Something like that. And I kept also my award like this in my home. Like that. Just like a ribbon. Like that. And then I kept also my certificate in being the champion of chemistry quiz bowl when I was in high school. I kept in my room, really. Okay, so that's a memory, right? Okay, so it's very good to have that kind of memories because you are becoming old, aging in the near future, and you have to share it also if you have a children, and you can share to the children. Oh my God, oh lolo, oh. So they will be inspired for you. Then if you don't have children, then you can inspire also your nieces, your nephews to do that the same as you. So it's an inspiration, an encouragement to them. Okay? That's my point really of sharing these stories. Real stories. Oh my gosh. Okay guys, thank you so much for watching this video. Going back na taoy kay I love na mo ko anak kong padayon na jud ko ani. Okay. Now, for example, if you have this let's say a tank, an open tank, because we need to illustrate the recovery, something like that, the generation and the accumulation and what is being consumed in your overall material balance, something like that. Okay, so it's gonna be like this, a tank. My gosh, it's an open tank lang siya, and then the opening is not just very big. Normally the opening of the tank is not very big, right? It's just only like this, and you have to close that every time. Okay, and then there must be an operator to control the tank every day. Okay, something like that. Okay, and this is our tank, and this is assumed to be open, a little bit open. Okay, I don't. This is the drawing of a tank. Oh my gosh, could it be a batch tank? Continuous? It depends on the type of tanks that you have in your process. Okay, so this is gonna be like this, ganon, chuba chuchu, and let's say this is half filled with water. We will start our example always with water, not yet a chemicals, right? So that we can avoid the difficulties in the behavior, the chemical changes, the physical properties. But because water is the very, very, very basic of all substances in the planet Earth. And we will, just so you observe, any instructors will always use this as an example, water. And then if not, the sodium chloride solution, like a brine solution, brine, or if not, it's just only a simple acid, like acetic acid, a vinegar, something like that, or sulfuric acid. Before going to other, complex chemical substances, it will start only for the basic, okay, being the simple one. Okay, because there's a lot of physical and chemical properties, then it will have a factor for your material balances also. That's why normally books always start with pure substance water in their sample problems. If you will observe the books, if you study different types of books in the library pertaining to the science problems, okay, whatever, chuba chuchu, it will start only with water, really. Okay, if it is a solution, it starts with sugar plus the water, okay, and then sodium chloride plus the water, nothing else. It will never go directly to the complex, chemical stuff. So that the students can understand, really, it starts with a basic, substance. Okay, it's gonna be like this, gonna chuba chuchu, feed, okay, and then product, like this, feed product. Okay, then generation. Even by generation. So generation meaning you have to generate in the atmosphere. Okay, meaning released to the atmosphere, generation, right? You got the point? So if you don't have a generation, you don't have the recovery. You don't recover something if you have generation. So zero. Okay, zero wastage. Okay, there's no wastes of your energy. Okay, so what's the point of recovering if there's no generation in the first place? Okay, that's why it will become a steady state material balance. But wait, I have to show this one. Okay, so generation, ganang-ganan, chupa-chuchu. Okay, generation, and then consumed. So this is in the field inside the okay, generation capital G. O ganon. Consume meaning the water will be consumed inside a tank. So let's say C, ganon chupa chuchu. I put C, consumed. Okay. G is for generation, so generated. F is feed or the input. P is the product or the output. Okay. Overall material balance or general material balance. General, all will be involved. Okay, like this. General material balance or OMB is equals to the accumulation. Nakakaloka. Okay, so accumulation, okay, diba, is equals to input minus output. Okay, you should understand this, if you will be able to project to become an engineer in the future, because this is useful for an engineer really. Okay, input minus output plus generated minus consumed. Okay, okay, mao gini siya permiga si general man siya, no, para masabtan nato, ha. Kung uban murid surar pa tag input is equals to output. Okay nya, ang uban nawala because that is steady state. Okay, like this. Okay, this is our weapon to become an engineer always, material balance. Okay, so we have this accumulation is equal to the input minus output. Why minus? Because the output will be released. So it's negative. What's being taken out will be negative. Just like you spend your money to buy gadgets, laptops, devices, or any food or groceries. So it comes out from your pocket. So automatically it's negative. It's the same story here in the balance or the overall material balance. That's why it's become negative output. Okay? If you buy something, it will become your output. It's not an input. Your salary will be your input, and your expenses will be your output. Something like that. You try to have an analogy between your income to this particular discussion. Okay. Plus, what's this? Generated minus consumed. Generated meaning there's a loss of the amounts of substances inside a tank. But normally, for the purpose of discussion in different books, we treat that as an ideal. Ideal meaning perfect. There's no losses at all. Right? So there's no generation. You get the point? Like that. And minus the consume. Let's say it's not yet consumed. Okay, normally during the process, it will become zero all. So if it will become zero all, the generated and the consumed, and then there's no accumulation, then input will be equal to output, because accumulation zero is equals to input minus output plus zero, then therefore we conclude at a steady state balance, energy balance, input is equals to output. Steady state meaning we are not concerned with the time here. Okay, bear that in your mind. We are not concerned for the time here. That's why it's called steady state. Okay, at any time interval. Okay, that's not our concern here. Or the time will seems to be negligible or irrelevant somewhere along the process. Okay, it's gonna be like the input is equal to output, and then a lot of problem solving focus only for this. Input is equal to output. Okay, especially the unit operations, the physical chemistry, something like that, or physics. But be careful also, because in the physics, sometimes fraction will be considered, fraction losses. Okay, especially if you are dealing with work. Okay, you remember that kind of problem? For example, pushing the piece of block in an inclined surface, that we need to consider the fraction. Okay, so the counteract of the applied force. Be careful also in physics, but here we are not dealing with that here because we are normally dealing with substances inside the tank. Okay, as our general balance. So this will be used also in relation to my discussion here in the combination of heat transfer through convection and heat transfer through conduction. That's why I relate this. Okay? Ganun siya. Okay? Mauna siya nahitabo. For example, if you have a 4 kilogram per second of your flow rate or mass flow rate, it is half filled already, right? So it will become 4, then half, it will become 2 in your output. So 2 kilogram per cubic meter. Okay, and originally your volume, like that, volume of the tank. So let's say the volume of the tank is 1,000 cubic meter. That will be your original volume. Okay, and your original volume at first kung full siya. Okay, and then your final volume will be the volume that it only consumed half. So that is your final volume. So that's the change of volume. Okay, so automatically the volume of the container will be also your original volume or your initial volume because the liquid will occupy the shape of the container or the medium. That's the property, the physical property of a liquid. Okay, if you remember in general chemistry lecture. So that's why the original volume on any medium or any container will also be your original volume. Volume means the capacity in terms of liters or gallons or whatever. Cubic meter, it depends on you, it depends on the problem that presented in the question. Ha! Ganon. Okay, but in here, I introduced only half-filled tank. Okay, ganon. So, going back to question number 2. Okay, so take a little moment. Oh my gosh, my coffee is becoming cold. Hala ka dyan. Sige, yaw-yaw. Hello guys, I'm not singing. Okay. I'm talking. Just like a monologue, I'm talking to myself without actual live audience, without face-to-face audience in front of me. Wow. Really? Okay, that's it. Okay, now, analyze this problem, guys. Oh, too lengthy, right? Okay, how can we understand this one? Charot. Ang technique bitawan niya, no? You will go to simplification of things out of complexity. Again, the goal and objective of problem solving, we need to target the simplicity out of complexity. Maol gina mo siyang timan-an. Okay? We need to deal with simplicity out of complexity. So if there's a lot of data that is now going to be complex, then we need to try to be simple, then simplify that. Okay, so what do you mean by simplification? We are trying to eliminate and reject data that is not relevant to our problem. That is only an operating condition. Take note this, ha? Okay? Engineers, take note this. Actually, this is very basic also to our engineering students. We need to eliminate and reject data that is not relevant to our problem because this will confuse us somewhere along the way. Okay, the purpose only is for the operating condition, but it is not related to our appropriate and suitable formulas to be used on how to solve the problem. You got a point? Ganun klaro? Okay, klaro siya. Okay, now, okay, this is gonna be a plain wall. Oh my gosh, a wall. Kakaloka. A plain wall that is 20 centimeters thick and has constant thermal conductivity of 3 watts per meter Kelvin undergoes a one-dimensional steady-state conduction. The surface temperature of the left side of the wall is known to be 50 degrees Celsius. Oh my gosh. And the right side of the wall is exposed to air with convective heat transfer coefficient of 60 watts per square meter Kelvin. The temperature, air temperature is 10 degrees Celsius. What is the temperature of the interface between the wall and the air on the right hand side of the plane wall? Okay, for example, this is my wall. I have to stand here, and this is my room, and this is the concrete wall. Oh my gosh. Here, in my room, I have so many walls around me. So this is, I think this is rectangular in shape. Okay, my room. So I need to, to determine the heat transfer through conduction, simultaneously the heat transfer also with convection out of that. Why? Because we have temperature in this environment. Okay? Hot temperature, hot environment, cold environment is impossible. There's no temperature. Or else we will die all without temperature. Okay? That is how important the temperature in our life. We will die without temperature. Okay? And I think our body core temperatures runs to 37 degrees Celsius to 38 degrees Celsius. Play around that range. Beyond that, we will develop a fever. Fever. So headache will come, or any symptoms of any diseases will come, so sickness will come. But what I'm trying to emphasize 37 degrees Celsius to 38 degrees Celsius, our body core temperature. Okay, for our cooling system, for all human beings in the planet Earth, including also living organisms, they should also maintain their body core temperature. All living organisms, the microorganisms, the earthworm, the protozoans, the amphibians, the family of mammalia, reptilia, species. Okay, in biology, remember that one? Phylum and species, different species, something like that. In a kingdom, different kingdoms. We belong to kingdom Mammalia as the highest form of animal on earth. Human being is also the highest form of animal in the kingdom of Mammalia. Okay, remember that one? That in biology, so many things like that to be learned also. Okay, but we are not concentrating here with biology, huh? Okay, so it's gonna be like that. So first, we need to find out what is being asked in the problem. Again, guys, what is being asked here? What is the temperature of the interface? Interface meaning the center. If there is a wall here and there's a wall outside, the metal is the interface. Only term, okay, interface. Alam dyan mo kalibog mo, yun na siya ang interface. Somewhere in the center, somewhere in the middle. Okay? So, mo gina siya term yung interface layer, interface boundary, something. Just like a chemical reactions, right? There's a lot of interfaces of the chemical reactions before producing the complete chemical reaction. It's gonna be like that, right? Okay. Alam ka mag-bulit, so na good siya. Imagine yung mga during, at the middle, of the course of your chemical reaction, whatever, chuba. Okay? Just like working from 7 o'clock a.m. to 3 p.m. Somewhere 7 a.m. to 3 p.m. there's a lot of activities to be done. Something like that. So that is your interface activities within that range from 7 a.m. to 3 p.m. if you are a day shift employees or whatever. It depends on the company if your time schedule. Okay, so that is interface activities within 7 a.m. to 3 p.m. So just like this problem solving, interface between the wall and the air on the right hand side of your plane wall. So klaro ka siya, plane ha, it's not surface. Because if it is, it's not rough surface. Because if there's a rough surface, then friction will be there. Friction. Okay, so that's why ni safe yun ang problem, plain good siya. Because so that we can use steady state, marok kayo siya ba? Okay, kung igamit mo ang rough, then friction will be there. So problem. So another complexity of your how to solve the problem. So as much as we could, we need to eliminate complexity and we need to target the simplicity of the problem so that we can easily obtain the answer, what is being asked on the problem. Medyo na siya goal per sa problem solving. Okay, regardless of how good you are in mathematical ability or regardless of how high your IQ really is, mao na siya purpose. We need to establish simplicity out of complexity. Okay? Di ba? Mao na siya bisag sa kalibutan mao gina atong purpose. Okay, di kayo ato yung samukon atong mga brain cells or whatever, then magsakit na nun atong kuan, lawas. Charot. Okay. Nakakaloka. Okay, we need a blank sheet of paper for that. Ganun kung yaw-yaw mo. Nakakaloka. Sorry for that. I'm very conversant. Okay. Oh my gosh. Okay guys, scratch paper. I need to save the scratch paper also to help save the Mother Earth. Okay, conserve energy resources also as one of the initiatives of OSH department to save also resources to help company costs also with regards to office supplies. School supplies. I'm not dealing with universities and institutions here. Okay, we are dealing with company. Okay, something like that. So to save also the cost, and then we need to recycle the waste papers or whatever. Since I can also write in the other side, then I have still to use common sense. I don't have to throw immediately. Di ba? Mga ganun mga bagay-bagay. Small things, nobody teaches us to do that. Okay? Just like throwing your waste, nobody teaches you to do that. It's instinct in you as a human being that you need to protect and nurture our planet Earth for our younger generations in order we have a sustainable environment. Okay? Sustainable. That it can sustain for how many years in the future. Or else they will be suffering, our future children, if we will just abuse our Mother Earth, our planet Earth. So we should act also as a little environmentalist in our small ways. Something like that. Even though nobody teaches us to do that. We don't wait for a safety officer to instruct to do that, right? Or a safety engineer or a safety manager to do that. We have the responsibility as a human being to care and to nurture our environment in order we have a sustainable environmental atmosphere or habitat. Habitat talaga, no? Okay? Ganun talaga siya, habitat, di ba? Habitat meaning a place, a specific place where the living organisms are living. Okay? Or the organisms are living. Okay? Like the fish, their habitat is the sea. The human being, their habitat is the land. Like that. You get the point? Okay, so that's habitat. Okay? Nag-environmental science naman ko dari-ari. Okay? Talaga. MSES. Masters of Environmental Science. Okay, go back to the solution. Problem solving na taga. No? Data. Yung mo din yung himay-himay yun. Scrutinize. Okay, scrutinize the data one by one. Oh my gosh. Ganun siya ba, di ba? Okay, so 20 centimeter thickness. Okay, very obvious. Thickness. Okay, let's just put that as X or L. It depends on the situation. But we have to put that 20 centimeter as our thickness. Isulat tayo mo, ganon. Okay. Then if you love also to diretso kay maayo na jud kay ka, then go. Okay, that is your convenient and you have the comfortability to do that. Okay, this is only for, proper way of discussion. How to solve properly any kinds of problem solving, right? Okay, now 3 watts per meter per Kelvin. Guys, even though there's no words thermal conductivity, it is automatically the thermal conductivity. Don't be dependent on the words. Just also consider the unit. Because sometimes problems in the future examinations doesn't necessarily specify what's that. The units speak for itself. You get the point? If I say watts per meter Kelvin, that is thermal conductivity. Something like that. If the unit is watts per meter squared Kelvin that is Stefan Boltzmann constant. Okay? So you have to be alert and you have to be clever enough to distinguish what particular unit is that. What is being referred to, and that would be your added advantage on how to solve the problems properly. Okay? It's very clear. Okay, now, thermal conductivity is represented by small letter K. Ganon. So, 3 watts meter Kelvin. Ingani gani guys, na murag, hala, pare-parihara man siya, uy. Ganon. You should also analyze, ha? Tanawar ko ang unit sa thermal conductivity, gukod-gukod siya gamay sa Stefan Boltzmann constant. Oh, okay. Ganon. Ipasok din yun sa inyong brain cells. Okay, that's the technique really. I've been doing that a lot when I was in high school and was in college. I need to determine the difference of the units. And then if it is similar a little bit, then bingo. Okay? So, practice memorizing basic units. Okay ha? Gamit kayo siya guys, really. Okay? 3 watts. Ayun mo pagsalik ng mga handbook. Handbook. Okay, kay kapoy pakli-pakli. In fairness, okay, maabtan dyan mo siyam-siyam. Okay, especially if there are terms na marag di takasabot. Okay, really. Okay, so 3 watts per meter Kelvin, ganun siya. It depends on the course you are taking, ha? But in our course, chemical engineering, there are times na jud mi kasabot, na at times. Okay, but we need to, to strive in order to understand. Okay, that's the main point here. In order for us to survive, to pass the subjects. Okay? Nadyo tayong guys, mahilak na, mahilak na gumisay, kanidyo masabtan. Okay, but okay, go lang. Go to the library until such time you can understand. Okay, really, lisod siya. I don't know, I cannot explain further, but, if you are in our shoes, then you can feel also what we felt. We felt something like that, okay? I'm telling you that the reality, okay, of, chemical engineering. Okay, so 3 watts per meter Kelvin, like that. Okay, money siya. Other given, guys, okay, the surface temperature on the left side of the wall, so mo-draw na yun ta. Okay, nihisgot naman siya ka ng mga kuan, mga orientation, the positioning of an object. Then, we need to illustrate because it is related where our, for example, our substance will move. Okay, that's the time we will illustrate. So let's say the surface temperature of the left side of the wall is known to be 50. So that's plain wall. So let's assume that we are taking only the side view of the wall. Because if we are taking only the front view, then we cannot determine the thickness of the wall. Right, so we need to consider the side view of the concrete wall or, wooden wall. There's a lot of types of wall, right? The most common are the concrete wall and the wooden wall, right? Ano pa bang mga ibang mga wall chuba-chucho? Okay, this is gonna be the plain wall. Okay. Guys, related din na siya sa insulation. Okay, problem solving. Diba? To maintain the heating and cooling system of, in a building. Because if we don't do that, then it will be causing overheating of those lines and equipment like that, AC, and then problem, it can cause fire and explosion somewhere along the way. Okay, so we need to have insulation. Okay, like that. So this is like this. This is a plain wall, side view. Ganon. Ay, nakakaloka. And then the thickness is 20 cm. Muna siya thickness, guys, ari. Okay. So 20 cm. Guys, what's really tricky in problem solving is that the questioner is not really having the units parallel to each other. Sometimes, like this, other centimeter, other meter. What if making them all same? So this is a problem also, right? And some students also will be confused, including me. Okay, it's gonna be the the normal process when you read a problem. Why like this? It's not parallel. Some centimeter. Sometimes also the unit is very far, and you have to convert first in order to have a parallel on your agreement of the units, so that you can cancel the units in your solution. In your, problem solving. Ganon. Okay? So, we need to convert. So, meaning pala talaga siya, they are testing, okay, the mental ability of the students, how far that the mental ability can extend apart from the basic, discussion in the classroom instruction. So, there's a goal of that book to be like that. Okay, or any author of the book that you don't need to limit your brain cells or your understanding within the box. You need to go out from the box and to analyze further what is going on. right? We need to say we should not be dependent on the sample problems. We need to go out from the box and let's see what gonna be the other problems might be. And then we need to practice how to solve problems, something like that. Okay, application naman guna siya sa theories, principles, and basic foundations so that you can apply really what's going on in the future if you're in the real world of working, being as an engineer. Okay, in different industries that you might be playing an important role. Could it be you are a mechanical engineer, electrical engineer, chemical engineer, instrumentation and process engineer, electronics communication engineer, application. Okay? Because if you don't have to apply what you learn, so useless. Okay? It's gonna be like that. Okay? That's the main target and the main goal. Okay? That's why, oh my gosh, the units are rambled. There's a meter, there's a centimeter, there's a feet. Oh my gosh, like that. So don't be in hurry. Take your time, something like that. Be patient. One quality of a good problem solver is to have a patience. Okay, and patience is a virtue. Okay, you will never become a hero if you will never have patience. Okay, everything in this world will not be obtained through quick and abrupt. You can get it immediately. You can strive how to get it. You will be failing. You will be succeeding somewhere along the way. But the main point, you have to do it slowly, gradually, and to be patient enough. If you don't have quality of patience, I don't know. You cannot achieve your goal. Okay? Like that. Just like solving a problem. Okay, you have to be patient. Okay? This one is a plain wall. Okay? Ganon siya. Okay, Sir Sotero, plain wall siya. So, of course, not a rough surface. Okay, plain ra good siya. So, smooth. Smooth. S-M-O-O-T-H. Okay? Like that. So, another given. Okay, 50 degrees Celsius at the right side of the wall. So, if this is my plain wall, where is the right side? Very easy. Tura dito ang left side. Okay, so 50 degrees ang left side. So, dari ari siya. Okay. So, let's denote that as our T1, our left side of the wall. Our temperature is 50 degrees Celsius. Okay. Himay-mayon ra gyud nimo class. You should scrutinize and investigate, number to number, terminology to terminology, quantity to quantity, and then troubleshoot the appropriate and suitable formula and try to have a little bit of analysis, then bingo, you can really get the answer most of the times. I'm not telling every time, most of the times. Okay? If not, all will become top-notchers. That all will be solved immediately. Okay? Ganun talaga ang buhay. Even though we feel that easy to solve, but somewhere along the way we will be in error because we are very fast writing the solution, and then so much erasures like that. And erasures can cause also errors. And just like me, I have so many errors due to that, and hugaw kaya akong solution sometimes, really. And then it lead me to errors. Okay? Muna siya nahitabo. Okay, dapat ikuan jud nimo is systematized. You do it systematically, and then write in a proper way, clean and clear, so that it will not add confusion to you somewhere along the way. But you have also to adjust, because examination is time framed. Okay, time framed, and there will be a time constraint for that also. What I mean is, if that is manageable, then go it in a proper way, ganon, and then review for the second time. Okay. Like that. Okay, T1 is 50 degrees Celsius, guys. And then, the wall is exposed to air with convective heat transfer coefficient of 60 watts per square meter cubed. Muna na siya yung mailhan that convection really persists or exists here because of the word convective heat transfer. Convective, it's a term from convection. That's why we need to combine here, convection na siya talaga. Though, it's not being mentioned here what's the substance flowing from this plain wall, okay, but it is understood to be that general only, okay, like that. No specific substance that will go in this plain wall, okay? Like, it's very easy because there's no substance are passing to this plain wall. Oh my gosh, right? You get the point? Ganun siya. My microphone is low but guys, okay? And I have to talk and communicate to you without microphone, right? Okay? Nakakaloka. Diba? Time check brought to you by Powdered Alaska Milk. 96.3 W Rock. Ganon. Okay? Grabe, may kantahan pa rin. Diba? What is that? Okay. 60 watts per meter squared. This is, guys, in convective heat transfer, what is the formula of convective heat transfer? It's gonna be based on my memorization. Wait. Okay. That is, my gosh. Convective heat of transfer represented as small letter h, just like the Planck constant, the Max Planck constant, right? So small letter h, and then times the surface area or the cross-sectional area times the change in temperature. Okay, but in here we need to consider the wall temperature and the free flowing or the free space fluid temperature because this is convection. Fluid or liquid talaga siya. When we speak about convection, it's not solid anymore. Okay? But in here, this is combination. So the convective heat transfer is small letter h. So the unit is not the same. All you have to distinguish between thermal conductivity and convective heat transfer coefficient is that in the numerator I will show you. Okay. 60. Mag-observe yun ta because being an observant is a quality of a scientist. Okay? And then you have a fair judgment of your inferences. Okay? Meaning inferences, you have to logical reason out of your observation. You observe and then you reason out based on your observation. That is inference. Okay? That's quality of a scientist. First, you have to gather the data through observation and then have your inference, and after that, you will elucidate your hypothesis. Initial educated guess out of your inference, and after that one you can guess and then you will formulate your body and content of your scientific discovery, and then you can establish your content on your theories like that, and scientific law, meaning a lot of equations that could connect to your theories, and then then you have the conclusion, the summary of your scientific theories. Those are the steps of a scientific method, of a scientific discovery, of being a scientist. Okay, that's why not all are given a chance to become a scientist. The main obstacle and barrier is the resources. It requires financial cost to obtain those equipment and technologies, very costly. Okay, because somewhere along your scientific discovery, you have to prove that through series of experimentation. In the laboratory, you will get sample like that, and you need to study that further. Then, for example, me, I don't have that here in my room. Okay, though I have the theory that it's gonna be the quality of a scientist, but I don't have laboratory here, and I will get sample of urine, and then I need to develop another element to be discovered under my name, something like that. But it's possible also that we can create and develop and discover another element that we will be able to introduce in the periodic table. Okay, if we have the study, then we can go farther, but we don't have resources, enough resources to do that. Okay, it's always the resources is the limitation, especially for the third world countries. The problems really are the financial resources for that, to be feasible. Feasible, feasible. That's why you have feasibility study. Okay, how realistic and to be put into actual your studies are. Because it's not also practical that you have the studies and you don't have the actual output for your studies, right? So it's, oh my gosh, it's useless. It's gonna be like that. So it's really financial resources for the equipment, raw materials like that. Okay, if you are really a scientist, anybody can be scientist. Okay, anybody. Okay, but only the financial resources sometimes, right? Okay, so if you really belong to the rich family, then you can do that. If you want really to discover something, but it depends also to the inclination of any individual. Okay, because there are also people who don't like science. Okay, don't like mathematics. They like politics. They like sports. They like chismis. right? So how can he create or establish or the discovery of another scientific theory? So like that, even though they are rich, billionaires and millionaires, it depends on the interests and the inclinations or the talent or, for that particular person, right? So it's gonna be like that also. There's a lot of reason behind for that. Okay, so H is equal to 60 watts per meter square Kelvin. So what yun yung timanaan, guys? The denominator of convective heat transfer coefficient and convection heat transfer, there's area at the bottom. But for the thermal conductivity, in the thermal heat transfer through conduction, only length matter. More gina siya diferensya. And bingo, that would be their respective unit each. Okay, so you will remember that and you will put that in your brain cells. Okay, get the point? Okay, ganun siya. Now, okay, at temperature sa air is 10 siya. Chararat. Okay, temperature sa air, so 10 degrees Celsius. And then, klaro kayo siya, guys, na the temperature of the interface between the wall and the air on the right. So this in between here, I will put a dot. Okay. So this is the temperature 1. Moni siya initabo. This one, I put an arrow to designate the clarity of the temperature, input temperature and initial temperature, or the T1. Okay. And I have also to designate the T2 here. The T2 here, guys, is unknown. Okay, so this is the one is being asked on the problem. What is the temperature of the interface between the wall and the air on the right hand side? So this is the right hand side here, right? By English, by an adjective referring to the side. See, right hand side. So it's being specified very clearly. So this is our T2 na talaga siya. Okay, kay interface man siya. Okay, and then the air. Now, this will be now our medium. And air is a gas, and that is categorically under the convection heat transfer. It's not limited only to fluids and liquids, it's also be air. Okay? So, ganun siya. So, nanatay combination. Heat transfer through convection and heat transfer through conduction. Now, how can we solve T2 here? Okay, now I discussed to you in my overview, in my introduction, the material balance. Now, we'll apply that here. Get the point? Thank you so much for watching, Mr. Jovi Morales, Jezzy Narvaza. Oh my gosh. Okay. Mga chemical engineering. Okay. What else? Okay. I have live audience now. Okay. Ganun siya. Okay, let's represent again. So ganito, accumulation is equal to input minus output plus generated minus consumed. Ganon. So this is steady state. So understood to be our generation and our consumption doesn't matter at all. So we treat those as constant, negligible, and irrelevant at this point in time. Okay, because that is our problem now. But in the future, maybe it will be also accounted. But in here specifically, we don't need that. That's why it will become 0. Okay, and there's no accumulation also because there's no introduction of any chemical reactions in the feed, in your raw materials, blah blah blah, so and so. So steady state will be applicable here. So we can just denote input is equals to output directly. Bingo. Okay, meaning out of complexity, it is now simple to understand. And now we meet our target and objective. Something like that. Okay, in every problems, you need to have your objective and target, of course. That's why that's being asked on the problem. Kaya maglutaw ra ka sa hangin if you don't know the target and objective on what you are really solving. Okay? So, ganun siya. Input is equals to output. Ganun. I don't have to put the zeros on it because I already discussed in the overall material balance. So, very easy, right? Algebra, basic mathematics. Not very easy, but very understandable. Okay? Like that. So, input is equals to output. My gosh. Okay. Ganon. O, diba? So, very simplified na siya talaga, di ba? So, what will be your input here, guys? The convection or the conduction? Then you have to analyze also that the air is going from the internal onto the outside because air is anywhere. So, in the surrounding, air is within there. Just like me, I'm sitting here in front of you, air is rotating around me. Okay? The only way to feel that is to through the feelings you have, okay? But you can never touch, okay? The air, of course, you can only feel that. So, meaning there's an air here around me, technically. So that situation, that will be our convective or convection. And our conduction, heat transfer, will be the air that will goes into my body. My body is a solid and going to the chair. It's just like that, an analogy. You get the point? So, your input will be the conduction. Okay? That's very clear. Because solid, as I told you in my previous introduction, it is a heat transfer through solid substance or solid medium. The movement of molecules is governed with that. Okay? And the convection also, the movement of molecules of fluid and liquids are governed with that. And air is a gas. Okay? So, nindot day ang kung ano ang conduction kay ni-focus lang siya sa solid. But then the convection focuses on the liquid, fluid, the gas. And air is basically an example of a gas or a vapor. Okay? So, ganun siya technically. Okay? And it's not our concern to define technically. There's a little difference. It depends on the sentence that we'll be able to use. Okay, if we will be able to do our research, scientific research, and we need to state specifically what's the difference between a gas, a vapor, and an air, but they are just equal in behavior, something like that. Okay, wala na tugi-tugi yung mga kunkuan, mga physical properties, but the same regular siya in normal judging of understanding. Okay? Like that. We will never go into the details man siya on the differences between vapor, gas, and air. Okay? Like that. So, input. Ganon. So, input. Ano sa itong formulas, guys? In heat transfer through conduction, we need to understand and memorize the Fourier's law of conduction discussed in physics and also discussed in momentum transfer under transport phenomena unit operations in chemical engineering. Okay? Like that. So what's the formula of that? And if that is the case, we need to consider the heat flux and the rate of heat flow. But we will go directly because we already derived a couple of days ago. So we need to be direct now to make it simple again, right? Okay. So it's gonna be like that. So input. Oh, ganon. So heat input is equals to heat output. Qi is equals to Qo. Qi is our conduction. So what's the formula of conduction? It's gonna be the thermal conductivity, K, times the surface area or cross-sectional area. It depends on the medium. If it is pipe, rectangular shape, trapezoid, rhombus, sphere, a cube, or any, as long as you know the geometrical shape of that particular object that you are referring to. Okay, that's the area. Okay, times the temperature gradient. What do you mean by temperature gradient? Is the temperature difference or the temperature change. Okay, so that is delta T. But I have to put directly the T2 minus T1. Okay, regardless which is the high temperature or the lower temperature. In this case, because it depends man asa jud siya sa problem ang gitaas ang temperature. Okay, we cannot assume permanent na talaga na anak siya. Okay, so T2 minus T1 over L. Again, we will do a derivation how to compute, really. Okay, so our QO, our Q output is the convection heat transfer. So what's the formula of convection? Andiyan na naman tayo. What's the theory behind this? This is discovered by Isaac Newton. Really? If Isaac Newton has the theory of, the three laws of motion in physics, which is the law of inertia, law of acceleration, and law of action or interaction, He has also the Newton's law of viscosity in the momentum transfer, and he has also this Newton's law of cooling process. Okay, you should not limit only to one study of Isaac Newton, huh? You have to maximize. Okay, because Newton also is in relation with the gravitational force in the study of planetary science, linked with Johannes Kepler. Okay, Johannes Kepler, three laws of planetary science also. Remember that one? And also linked with Albert Einstein, the theory of relativity through times and space in the outer space in the universe. Ganon. Diba? Oh, ganon. So, output QO is equals to, the formula of convection heat transfer will be H. Sugi kumiyaw-yaw, no? H times the area. Okay. Now, there's no length in the denominator for the heat transfer of convection. Unlike the conduction, there's a denominator L, or the thickness, the denominator. But here, there's no denominator. Okay? Like that. So, here, T2 na siya. Because in your drawing, if you consider this plane wall, your T2 and your interface will become now the initial temperature also in the convection. This is become now the reference as T1 and then represented as T2. So T2 minus T air surrounding. Okay, ganun siya. Okay, so T2 minus T air, or we can call that as the temperature of the wall at the output, TW, output not the input. Okay, minus the free space or free flowing temperature of your fluid, liquid, and gas. Since air is a gas, then automatically we can say that this gonna be our temperature infinity, right? Because air is infinite. You can never measure air at all times. It is infinite, and we cannot measure that one. It's immeasurable. Air in the planet Earth. Okay, we cannot compute them in every second like that. We know that there are constants, but we cannot compute the behavior in the air. We cannot compute that every time. Okay, so that is infinite. T infinite is just equal to T air here. Okay, it's just happened that we have the gas here, not the liquid and the fluid. Again, our close and open parenthesis here is the wall temperature at the outer interface layer of the plane wall, which is designated actually with TW. Then since TW is equals to T2, then we can say T2 is equals to T minus T air, which is the T of the infinity. Oh, ganon. So T2. Now we have T air given, which is 10 degrees Celsius. Substitute that one. So meaning to say, in this particular problem, our T infinity, our T air, or our convective temperature at the outer layer in the air surrounding is equal to 10 degrees Celsius, right? Ganon. Okay. So minus 10 degrees Celsius. Okay, like that. 10 degrees Celsius. Ganon na siya. Through this linear equation, substitute values, then bingo, we can solve what is being required. Direct substitution, but you have to analyze what's going on in here through steady state heat transfer combination of conduction and convection. And I thank you. Ganon. Diba? Ganon yung mga atake. How to solve the problem. Okay, so let's need to cross multiplication for this, because there's a denominator on the other side, and all you have to do is you have to cross multiplication in algebra or in the basic math. So you have to put 10x and you have to follow the direction and multiply that individually. Ganon. So how can we do this? Okay, so HA T2 minus 10 degrees Celsius times the length. Oh, ganon. Okay, HA is equals to T2 times minus 10 degrees Celsius times L equals to KA T2 minus T1. Guys, notice guys, what is the common in the left and right side? I told you a while ago. Common ang capital A in the left side and the right side. Remember, this is the area, right? Since our plane wall did not specify the length and the width, so obviously we don't get that individually. So it will be cancelled only through the steady state equation. Cancels the capital A, our area will be automatically eliminated. So reducing another quantity so that we can attain simplicity out of complexity. Okay? Ganon. Cancel the A. So, unsay nahabilin? Take note. We have values here. Then substitute that here. Okay, ganun siya. Okay, guys? Okay, so ano na siya nahitabo. Okay, thank you so much, Bro Jesse Narvasa. Yes. Kaya gyud ni nato tanan. Charot. Okay, so H, atong ikuan ang H nga mo ni siya 60 watt, okay, meter squared, because this is the convective heat transfer to convection. I-substitute ito ang H. And then T2, wala pa siya. Okay. T2 minus 10 degrees Celsius. Okay. Ang length, wala pa. Meron siyang length, guys. Dire-ari, a plane wall that is 20 centimeter thick. So it could be also your length. As I told you over and over again, sometimes the length will become a thickness. It depends on the perspective on the problem. Okay, now the length will be 20 centimeter. Again, convert that to meter. That is 0.020 meter. Kay zeros naman ang atong i-divide. Move 100. 1, 2. It is 0.02 meter. To make it sure, use the scientific calculator. Okay, I will not rely my brain cells. Okay, 20 divided by 100. 0.02 tingalin ni siya, uy. Okay, 20 divided by 100. No, it's not 0.02, 0.2 lang siya. Okay, so 0.2 meter. Substitute. Ganon, chuba-chuchu. And then, thermal conductivity. We have 3 watts per meter Kelvin. Then substitute that here. Oh gosh. Okay, so 3 watts meter Kelvin. Okay, now T2. Wala kay T2. But ang T1 ni mo, specified here, is gonna be 50 degrees Celsius. Then substitute that there. Okay, so 50 degrees Celsius. Okay, ganon. Okay. Now, after substituting, what did you notice? Notice the parallelism of the units and the quantities. There's Kelvin in the denominator of your convective heat transfer coefficient, and there's also Kelvin in the unit of your thermal conductivity. And you have degrees Celsius in your temperature gradient. So, it could either be you convert the Kelvin of your thermal conductivity and your convective, or either converting the Celsius in your temperature gradient in your convection and your conduction equation. It's gonna be like that. But for me, I'll choose to convert the Celsius directly because it's very easy, rather than converting the thermal conductivity in which it is given already, something like that. And there's a lot of, cancellation of units because there are 3 units involved. Watts, meter, Kelvin. And then here is only Celsius. It's very easy, right? So Celsius is equal, temperature in Kelvin, so that we need that to be in Kelvin. So temperature in Kelvin will be equal to degrees Celsius plus 273.15. That's gonna be our Kelvin values. Now we will add only 273.15 in 10 degrees Celsius for the temperature in air, and we have also to add 273.15 to the temperature in the air. Ganun siya. So plus 273.15 plus 273.15. So pila man siya. Okay. Scientific calculator. Wow. So 10 plus 273.15. Oh my gosh. 10. So you need to be careful, guys, that we need to add really all, if that is in terms of degrees Celsius, because your unit of thermal conductivity and convective heat transfer are also in terms of Kelvin in the denominator. And you must be watchful and observant for that, because your answer will become wrong if you will never troubleshoot the consistency and the similarity of the units. Got the point? Okay, that's very clear. Okay, 10 plus 273.15. Okay, so it's gonna be 283.15 Kelvin in the temperature of the air. Okay, so 283. I just put open and close parenthesis beside the value of the degrees Celsius, huh? Okay, like that to save the space. So this is Kelvin already. And then 50 plus 273.15, how much? Okay, 50 plus 273.15 is equal to 323.15 Kelvin. Oh my gosh, nakakaloka. So close and open parenthesis, 323.15 Kelvin. And now bingo! We can solve now for the value of the T2. Ganon. And now let's check, double check if the units will be cancelled somewhere along the way. Okay, now. Okay, what's on the other side? Cancel. Because left and right, the same unit cancel. Okay, that's the, in science, it's going to be the basic rule. So cancel the W, cancel the W. Okay, and then if we times the Kelvin to the meter squared Kelvin in the denominator of this heat transfer, meters also will be cancelled. Kelvin will be cancelled. Okay. And also this meter will be cancelled because we are multiplying still with the thickness n. So n will be cancelled. There's still meter left in the denominator. Okay. And then on the other side, okay, again, meter, no, it will not be cancelled because that is not meter squared. There's no other meter in that other convection. Okay. So all we have to do is to cancel the Kelvin and watts. What will it is meter? So meter and meter on the other side. So again, it will be cancelled all. So what will be left is the temperature na talaga siya. Okay? Muna siya nahitabo. So, temperature na ang mahabilin. So, we've got this. T2 is equal to 18 degrees Celsius. Okay? 18 degrees Celsius. Okay? Okay? So, do the mathematics here. Like that, and you can obtain 18 degrees Celsius. I don't have to show it because, this is very basic in algebra. Linear equation language siya. Transpose, ganon. Then if I have to show it, then that would be a plus factor. That please do that by yourself also. Okay? To avoid spoon feeding discussion also, right? Okay? That's too much spoon feeding. Okay? Just perform the basic operation. What is left here is T2, then bingo, you can solve for T2. And then based on the answer is 18 degrees Celsius. Okay, like that. And this is the problem for that. Okay? Like this. Oh my gosh! And this is what's this? BS Chemical Engineering Board Examination, November 2021. Okay? This kind of problem is BS Chemical Engineering problem, November 2021. Okay? November is very difficult examination compared to May. But it depends also, right? So, because there's a lot of students will be taking at that November compared to the May. Usually the May are the rate takers. Okay? But there's also fresh takers, but I am telling only most, but not all. Okay, like that. So, it's gonna be the answer is 18 degrees Celsius for the particular problem. Any questions so far for this combination of heat transfer through convection and heat transfer through conduction? Oh my God. Any question? Because I have to take my dinner now, guys, and I have to, again, do in our segment number 3. See you later also. Any question? Uy, thank you, Kayo ninyo. Thank you so much. Master Gizzy Nervaza, Joy Morales, Juvie Morales, and Chisif Cantal. Okay, mga konjini sila mathematics or science case. Tanaw gid sila. O, diba? Ganun. Thank you so much for the support, guys. I love you all. Char, parang artista. Kaloka. Okay? When ako mag-yellow, ha, they will interpret me as, supporters ko ni Lenny Robredo. Okay? Laoy, the coffee is very delicious. Delicious. Tastes good. The aroma is good. My gosh. Guys, I need to eat my dinner at this point in time. So see you later for my third session of live streaming and vlogging. Okay, this is again, I'm a singer, eternal voice, a YouTube content creator, a social media influencer, a small YouTuber. Okay, then if you like this video, you can just comment down below in the comment section. And then if you think that we are not yet friends and you are not yet my follower, then you have the full freedom to subscribe my YT channel. I will be happy for that. Okay, and then you can click also the notification bell for some newest updates of I am a singer, eternal voice. And somebody asked me why I am a singer. Because I treat myself as a singer in my own little way. Okay, that's my freedom also to brand myself. Okay, so even though I'm not a professional singer, but I can sing, right? So that's why I put I am a singer, eternal voice. Eternal voice meaning I can do a lot in singing. Okay, okay, like that. A lot means general, ha? It doesn't need to be specified. Okay, that's why eternal voice. Okay, got the point. But most of my genre is biritan. Okay, pop song. Okay, something like that. Slow pop song. I can also sing fast beat song, upbeat song, or a little bit of R&B like that, or any rock music, especially songs from, songs from Queen, songs from Scorpions, and songs from Aerosmith. Okay, and also songs from the air supply is not really a rock, right? It is just a pop song. I can also sing air supply songs. Okay, that's it. So meaning to say, I need to be versatile. Okay, something like that in order I will not become boring. The boring in my video and live streaming is that I don't have creativity. I don't have special effects. Okay, in my screen, I don't have the dramatic effects in my videos because I'm not really that good at it. I don't have software to do that. I don't have time also to study for that. Okay, because my only purpose is to share academic information, like this. I don't have no, and I don't have. In fact, I don't aim to have a big revenue. Okay, this is just only for additional, fulfillment, happiness, and contentment. Being a licensed chemical engineer and also a legit OSH engineer presently. Something like that. Thank you so much, guys. Bye bye, everybody. God bless everybody. See you later. Woo. Naman. Wow. Kakaloka.